at an example to solve one-dimensional heat equation using two-level formula. Solve dou u by dou t equals dou square u by dou x square such that u of x0 equal to sin pi x, u of 0t equals u of 1t equals 0, take h equal to 1 by 3 and k equal to 1 by 36. We are also given with the mesh in the question, and we can see the boundary conditions defined. We know that the values corresponding to 0, 0, 0, 1, 0, 2, the values corresponding to 3, 0, 3, 1, 3, 2 all are equal to 0 as seen from the boundary conditions. Also the values corresponding to the positions uij equal to u10 equal to root 3 by 2, u20 equals root 3 by 2. So from the mesh itself it's clear that when you try to draw the table, the column I equal to 0, the first column, and the column I equal to 3, which is the last column, takes all 0 entries, and u10 takes the value root 3 by 2 and u20 takes the value root 3 by 2. Having found all the values of the first row, we can easily find the values of the second row using the recurrence relation which is obtained from the two-level formula. From the question it's clear that c square is the coefficient of dou square u by dou x square. Therefore we obtain c square equals 1, h equal to 1 by 3, k equal to 1 by 36. Therefore we evaluate alpha equal to k into c square divided by h square, and we obtain the values 1 by 4. In the standard two-level recurrence formula, we substitute alpha equal to 1 by 4 and we obtain uij plus 1 equals 1 by 4 ui minus 1j plus 2 times uij plus ui plus 1j. So this is the formula which has to be applied in this question. We can see that if we want to write the value here, what we have to do is we take 0, root 3 by 2 twice and root 3 by 2, sum all those values and multiply it by 1 by 4 to get the value here. That is 0 plus 2 times root 3 by 2 plus root 3 by 2. The answer of the sum multiplied by 1 by 4, we obtain 0.65. Similarly, to obtain the value here, what we have to do is root 3 by 2 plus 2 times root 3 by 2 plus 0. The answer of the sum should be multiplied by 1 by 4 and we get the answer to be written here. When we find all the values of this row, to find the values to be written in the last row, again we depend on the same formula. The value to be written here is 0 plus 0.65 into 2 plus 0.65. The sum of expressions is multiplied by 1 by 4. And we get 0.49. To get the value here, what we have to do is 0.65 plus 2 times 0.65 plus 0, and the whole sum is multiplied by 1 by 4 and we get the answer here. We may also depend on the recurrence relation we obtained. We just give j equal to 0 to obtain the value across j equal to 1, and you just iterate I equal to 1 and 2 in the standard formula. We get values u00, u10 and u20. We substitute the values. In that case also we get the values 0.65, 0.65, 0.49, 0.49. To obtain the values across j equal to 2, we have to substitute j equal to 1 and iterate I for values 1 and 2. We obtain the standard values to be written at u12 position and u22 positions. In that way also we can find the answer. So in the question we were asked to find the values of uij corresponding to the positions 1, 1, 2, 1, 2, 2 and 1, 2. We already found the answer. Thus we can conclude the solution. But if we wish to analyze the problem a little more closer, look at the standard function given in the question. U of x0 is equal to sin pi x, and we have been given the scaling of variables x and t. That is, the spacing of variable x is 1 by 3. So we have the equation x is equal to I by 3. The spacing of the variable t is 1 by 36. Therefore we have the equation t is equal to j by 36. So in these standard equations, if we substitute I equal to 0, we will get the value corresponding to u00. When you substitute I equal to 0, you have x equal to 0 from this equation. So when you substitute x equal to 0 in the standard equation ux0, you obtain u00 equal to sin pi 0, which is equal to 0. If you want to find the value for I equal to 3, that is the value to be written here, you substitute I equal to 3 in the standard equation and you get x equal to 3 by 3 which is equal to 1. So substituting x equal to 1 in the standard equation, you get u1 0 equal to sine pi, which is again 0. So from these two conclusions also we can verify that the boundary conditions are true here, or the columns I equal to 0 and I equal to 3, that is the columns 1 and the last column are having 0 entries, is verified through these deductions. Now we will have to verify if these two values are valid here, that is the entries root 3 by 2 and root 3 by 2. Calculation is like this. When you give I equal to 1, we know that this position is I equal to 1, j equal to 0. So substituting I equal to 1 here in the standard equation, x equal to I by 3 becomes x equal to 1 by 3. Applying x equal to 1 by 3 to this formula, you get u 1 by 3 0 equal to sine pi by 3, which is root 3 by 2. I equal to 2, which is the position I equal to 2, j equal to 0, you get x equal to 2 by 3 when you substitute here. When x equal to 2 by 3 substituted in the standard equation, you get u 2 by 3 0 equal to sine 2 pi by 3, which is again root 3 by 2. So all the boundary conditions given in the question are valid and it follows the standard equations and deductions given in the question. So for examination, you have to just evaluate alpha, write the general expression of two-level formula and find out the recurrence two-level formula applicable to the question here by applying alpha equal to the value obtained. Using the boundary conditions, sometimes you will be easily able to complete the table, and you can also show the deductions which are obtained from the recurrence formula to get the desired values. So thus you can conclude your solution.